Starting out with number 1. Can I get a volunteer to read out what number 1 says for everyone? Go ahead, Zach. Okay, hold on. We're going to listen to Zach. Go ahead.
A Canadian goose migrated at a steady rate of 2 miles every 4 minutes. A, fill in the table to describe the relationship.
Okay, perfect. We're going to stop right there. I appreciate it, sir. So, Canadian goose is migrating 2 miles every 4 minutes. Okay? I look at my table. X is minutes. Y is miles. So after 4 minutes, how many miles did it migrate?
2.
2. That's just the information that we're given, right? Right? After 4 minutes, it migrated 2 miles. All right? And we see we've got a change of 2 on the bottom, right? So how much time has passed if it flew 4 miles? 8, right? We're just continuing the pattern.
12.
The next one's going to be 12. Right, and we see we got plus 2 down here. What's my next?
8.
Okay, 8. What's this box here going to be? 0, because if there's no time passed, how many miles has the geese flown? 0, right? So what type of relationship is this right away when we see that? Proportional. Good. All right. So we're going to graph the relationship. We'll take a look at the graph here. Okay, and something we really need to be paying attention to is our axis, right? Right here is my time. Is each little notch on this axis worth 1 minute?
No.
No. How much is each little notch worth? 2 minutes. How can we tell that it's 2 minutes each notch?
Because 10 divided by 2 is all.
Because there's 4 notches before 10, right? So it wouldn't make sense for it to be 1 minute, 2 minute, 3 minute, 4 minute, 10. But it would make sense to be 2 minute, 4 minute, 6 minute, 8 minute. 10. Okay, what about my distance here? What is each notch worth here in terms of miles? 2 of them, right? Same thing. 2, 4, 6, 8. So the graph is not always going to be 1 to 1. That's something we have to be paying super careful attention to, okay? When I'm going to graph now, I'm going to graph the point 0, 0. Of course, that's at our origin right there. I've got a point at 4, 2. So at 4 minutes, the geese flew 2 miles.
Balloon.
I don't know. There's going to be that point right there. And then 8, 4, 8 minutes, 4 miles. Hopefully you guys are seeing the pattern now, right? 12 minutes, 6 miles, and then we could continue this pattern all the way up to there.
This was not the one I was confused with.
I know. Number 2 is more confusing. We're going to start out with the easier one.
Where did you get the point from?
All right, there's my line. Anybody's line look just like that? Cook shell thumbs. Anybody? Anjali, Ryan, Alyssa, Khalees. Okay, good. It's okay. If your line doesn't look like that, are you getting it copied down so that it does look like that now? Okay, good. That's what we should be doing.
Trying to get full credit.
Good. So now what we're going to do is find the slope of the graph. Again, there's 2 ways we could find the slope. We could use the graph, do rise over run, or we could use the table and do our arrows over our arrows. Let's do the table because we already did it. Right? What's my change in y on the table?
2.
2. Okay, change in y over change in x. My change in y here was 2. What's my change in x on the top?
4.
4. All right. What are my units for the 2? 2 what? 2 geese?
Yeah. No, 2 minutes.
2 minutes?
2 miles.
2 miles.
I should say geese.
Is it in a geese? Yeah, it's a goose.
No, it's miles.
1 goose, whatever.
I'm confused. But
About the math or about the geese?
about the geese.
Okay, we're not going to worry about the geese. The geese don't exist, okay? So this is what we get for the slope. 2 miles in 4 minutes. That's the information we got from our problem.
You can simplify it.
Ladies in the front, you guys all okay? All 4 of you? You guys good?
Yeah.
Okay, I'm just making sure we're paying attention. Okay, because I'm hearing a lot over there. 2 miles every 4 minutes. Zach said we could simplify. How can we simplify 2 over 4?
1/2.
1/2. Okay, my units are miles per minute. So half of a mile per minute. When it says describe what it means in the context of this problem, that means the goose flew 1/2 of a mile every minute. Okay, Eva, Sheena, you guys making sure we got that down? Goose flew 1/2 of a mile. This sentence here we got? Goose flew 1/2 a mile every minute? Okay. That one's a little bit tricky because we have a fraction slope, right? That's probably why we got a little bit tripped up on that. But any questions I could answer about that first one?
Not really, it was pretty easy.
Okay. There is something on the test very similar to this one. The second one, not so much. Okay? Now for number 2, we're comparing 2 separate machines. Machine number 1 is represented with a table. Machine number 2 is represented with a graph. What is this graph missing in machine number 2? What do we normally see on a graph that I don't see here? Dots. I don't see any dots, so we got to make our own. Okay, I'm going to zoom in. I can see, okay, my graph is going, there's a 5 here. So if I fill in the blanks, what is each little notch going to be worth? Is it going to go by 2s like the other one? It's going to go by 1s. 1, 2, 3, 4, 5. Same on the Y. 1, 2, 3, 4, 5. All right? So where do we see a point along this line? I definitely see one at 0, 0, obviously. Where do we see another point? What coordinates? Anyone see a point there? 2, 1. 2, 1, boom. Where do we see another point? Any other points you see? That's the only point on that line? 4, 4, 2. All right? 6, 3. Every time you see the line pass through the graph at an even, cross, that's where we have a point. Okay, so I can use any of those points if I want to find my slope. Let's go back and see what we have to do. So the first thing we need to do is find the unit rate. Again, that's just m. So we're going to find our slope for each machine and explain what it means. So let's look at machine number 1 first on the table. If I have a table, how can I find the slope of that table? Graph it. Change in y over my change in x. That's right. So what is my change in y here? From like 1.2 to 1.8. What am I adding to that?
Is that a negative sign?
This? No, that's just a printing thing. We're doing plus what, Alicia? Plus 0.6. Good. Okay, guys, let's pay attention, please. Ladies in the middle. Okay, please pay attention. Stop talking. How do you get from 2 to 3? Plus 1, right? So my slope here is going to be 0.6 over 1, right? 0.6 gallons per 1 second. How can I simplify 0.6 over 1? What does that turn into? 0.6, right? Gallons per second. Okay, that's my first slope. For my second slope, I'm going to do rise over run because I'm looking at a graph. Right? So if I start at the leftmost point here, how many units am I going to rise up from this point? If I'm going from this point to this point, how many units am I rising up? 1. Okay, so my rise was 1. How many units am I running over to the right? 2. So my run is 2. Okay, still my units are gallons per second. And now because our first slope is a decimal, I know normally I say I hate decimals, but for this problem, we're going to turn this into a decimal. What does 1/2 written as a decimal look like?
0.2.
Close. 0.5 gallons per second. So machine 1 is bottling soda at 0.6 gallons per second. The second machine is bottling at 0.5 gallons per second. You guys see how we got those two numbers? Okay, one was a table, one was a graph, but we use our different ways of finding slope to be able to compare the two, right? So which one of these is going faster, 0.6 or 0.5?
0.6.
0.6. So machine 1 is going, or we could say is bottling 0.1 gallons per second faster than machine 2. Again, we're not going to have to do anything that complicated on the test.
Thank God.
But you are going to have to find slope from a table. You are going to have to find slope from a graph. So if you didn't know how to do that, hopefully that helps clear some things up. Okay? Any questions we can answer on that? Okay. On the back, just very quickly, because you guys said you seemed good on that. Is number 4 variable or constant? Constant. What's my M here going to be? 30. 30 what?
30 miles per hour.
30 miles per hour. Good. What's my answer number 5 going to be? Variable, right? Because on my Y, we've got +9 and then +6. So this person is slowing down their Cheeto eating as time goes by. They're not eating at a constant rate, right? So I can't even find an M because it's variable, right? Number 6, what do we think for this one? This one is variable too. Now you may get tricked, right? You see, oh, on the bottom I got +10, +10. So why is this one variable if +10s are the same? The top is different, right? +2, +1. That's not what we want to see. Variable change there as well. What about number 7 though? That one's constant. What's my M equal to for number 7?
M is 5.
5 over 10. How can we simplify 5 over 10? 1/2. What are my units? Rotation per second. So half of a rotation every second. Right, so we're not going to hit one full rotation until 2 seconds has passed, right? What about number 8? Constant or variable? Constant. What's my M for number 8? 1/2 again. Naps per day. Oops, there it is. Now for something like number 8, you may be thinking, how can you take half of a nap in one day? Right? You can't. So that's not what this M represents. This rate of change represents, essentially, you're taking one nap every other day. So I take a nap today, I don't take a nap tomorrow. If I take the average, now I'm taking half of a nap per day. But you can't actually take half of a nap, right? Do you have a question about that one? Perfect. You're not wrong, but we want the unit rate, right? So 1 nap per 2 days. My second quantity is not 1, so it's technically not a unit rate. So we just want to simplify it, half of a nap per day. I know it sounds weird, like logically when you think about half a nap a day, but 1 day, that's what we want. We want our second quantity to be 1. What do we got in number 9? What'd you get for number 9? Variable. Thank you. How about number 10? Variable again. I got +5, +3. That's not good. Slowing down our haircuts. And number 11. Variable again. We got +180, +280. And we got +2, +2. Yep, that's not going to work. Variable it is. So, real quick, just to check in again, how confident are we feeling about the back? We feeling good?
Real good.
Real good. Really good news
Absolutely.
for me. Okay. We should all be done with this now since we just went over the entire thing. If you need an extra day, you have 3 of them. Right? When are all your missing assignments due again?
3 days.
Friday. Thank you, Jawad. Friday.